this is Paul Baumgarten and welcome back to my series of videos on learning to program with JavaScript. And we are going to dive right in. In the previous video, we looked at creating functions, why we would use one, how we could create one. And towards the end, we looked at functions returning values as well as them just being used to provide a nice way of reusing code. Today we are going to look at the subject of iteration or repetition, as it is also known as. So what are we going to do? Let's get Coding with Chrome up and running into our advanced mode. Programming with JavaScript on an empty project. Having said that, I don't really want an empty project. If you're smart enough to save your stick person project or whatever it was you did last time, how about you bring up your stick person function? Now I'm just going to cheat by copying and pasting mine across from my other notes. There's my stick person from the previous lesson, and I could just run it by using stick person 5050 or some such, and it still works. That's always reassuring to see. Okay, so today, iteration or repetition, or whatever term you want to use, but basically getting the computer to do one thing over and over and over and over again. Something that computers are very good at and humans are bad at. Get a human to do the same job continuously non-stop and we will get bored out of our brain. Just ask people working the factory lines in, yes, some unfortunate place. Anyway, let's not digress. Computers don't get bored. Computers are very fast at performing very simple calculations. So the computers themselves are not that powerful. Their power comes from their speed. And so they can do simple calculations, but they can do very fast, billions of times per second. So what on earth am I getting at here? Last lesson, we were drawing an army of stick people when I left you. Well, then I had you draw your own things. So, and I ended up having a whole pile of statements looking something like this. A whole pile of stick people being drawn on my screen. Now, the whole benefit of using the function was so that I didn't have to write out these 8 lines of code plus the 3 comments, 11 lines of code every time I wanted a stick person. And so I can draw a stick person just once. But if there is a pattern to my stick people, in this case, my x value is incrementing by 100 each time until I've hit 550, and then that resets, and then my y value has incremented by 100. If there's a kind of a pattern like that, where there's an order to the progression, surely I can just tell the computer, draw me another stick person, but increase the x by 100. Then draw me another stick person and increase the x by 100. So I don't have to write this all out 5 times here and then another 5 times down here. Well, sure enough, yes we can, because computers are great at repetition. And there's a couple of different ways that we can do this. The first way that I'm going to show you is with a thing called the for loop. Now, inside a for loop, it gets a little interesting. So the basic construct of a for loop, and it's still not enough to get rid of the error because, okay, yes, if I put in 2 colons and now coding with, I know what's going on here. All right, I was just trying to get my stick people back up and then go through this explanation, but there's reasons why this is happening, which will become evident momentarily. All right, the basic construct of a for loop. So basically, what we mean by a for loop is, suppose I gave you the English expression, for 10 times do this, okay? Or in this case, if we're looking at something like the x value and we're wanting to move it along, okay? For an x coordinate starting at 50, increasing by 100 every time while your x coordinate is less than or equal to 550. Draw me a stick person. Okay, so there was 3 bits of information that I just said there. Okay, in terms of the conditions that I was describing to the computer. All right, so I said for an x, I'm going to use the comments here to try and give me a space to articulate this. For an x coordinate starting from 50. Okay, what do I want the computer to do? Okay, starting from 50, and I want it to keep going up until 550. So until, or while the x coordinate is less than or equal to 550, okay? Because I want it to happen here, 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 and then I want it to stop, okay? And then what do I want to happen? Okay, so this is saying when I want it to start. This is kind of telling me when I want it to end. And then for each time, okay, every time it draws me a stick person, what I want it to do, increase the x coordinate. Oh, it helps if I spell coordinate right, doesn't it? By 100. Okay, let's put in this over there. Okay, that's what I want it to do. 3 pieces of information that are part of the instructions that I'm giving JavaScript for drawing my stick people. Okay, so at the moment we're only looking at these first 6 stick people. So we'll get rid of these other ones, but we'll come back to them later. Okay, how can I get this to happen? Okay, so so I use a variable. We should be used to the idea of using variables by now. Okay, and again, let's call this variable x. So outside of a for loop, we're used to the idea of, if I wanted an x variable starting with 50, I would do something like that, wouldn't I? Well, it just so happens that's exactly what we do. But I put it inside my for loop, including the semicolon. Now the next thing is while the coordinate x value is less than or equal to 550. Okay, so that's x less than or equal to 550. Another semicolon. What do I want to happen each time? I want to increase the x coordinate by 100. Okay, if I had a value that I wanted to increase by 100 outside of a for loop, I could have done that. All right? Take the value that's in x, add 100 to it, store it in x. Okay, so a reminder that this is not an algebraic equals, this is a computer program assignment. Okay, where basically whatever is on the right gets calculated, evaluated, a result found, and gets stored in whatever is on the left. Okay, so that would be the way to do that. I don't want the semicolon this time, so I'm just going to cut that and paste it in here. Okay, these functions have started working now. Okay, I no longer have a statement here that is illegal and causing JavaScript to spit the dummy at me. All right, but there's my 3 things. All right, an x coordinate starting from 50, x running. So basically, I want this whole thing to keep on looping while this part is true. Okay, so while x is less than or equal to 550, and then each step of the way, I want this to happen. Now, I can't remember whether the variables video showed this or not. There's actually a cheat or a simpler way of showing this. Okay, these two things are equivalent. If I just quickly type out these lines, x is equal to x plus 100. Another way I could write that is that, okay, this is just shorthand notation for saying take whatever's here, keep it the same, but add this to it. Okay, these two lines are identical in terms of what they do. Okay, so on that note, I will come up here and I will replace this with a plus equals because it's a little shorter. Okay, I've written a for loop. Let's look inside the curly braces. Okay, so for loops start and stop with curly braces the same way functions do. Okay. Now let's get rid of these lines and let my for loop draw my stick people. Okay, just as with functions, I indent because I'm inside a set of curly braces, and I'm going to go stick person. And this time, I want the x value for my stick person function to be based off this x value here. So I'm just going to type in x, and I'm going to position it at 50 to start with. And look at that, I have 6 stick people. Starting at 50 and running through to 550. And my mouse just died on me there. Okay, so 50, x value 50, x 150. All right, I can change this gap. Let's make it 70. And we've got a whole bunch more stick people. Let's make it 60, and they should be touching heads. Oh, look at that, they're getting very cozy. They're all holding hands and interlocking feet. How cute. Okay, and instead of stopping at 550, how about we just stop it at 50? Well, we stop after the first one. Let's make it 200. Let's make it 300. Okay, so keep going while this statement is true. So there are 3 parts to a for loop. All right, there is the what do you want to do at the start of the for loop? Semicolon. Give me a statement that tells me how long you want to run the for loop for. So while this second statement is true, we will keep looping. Okay, so start with this, keep looping while this is true, and at the end of each step, run this. Okay, so those are the 3 parts. Get rid of those comments. All right, so in here, now if I want my second army underneath, I can do that. And I can put another row. And all of a sudden, it starts to occur to me that I'm just incrementing my y value by the same amount each time. Surely computers have a way of where I can just tell it to just keep repeating itself and increase this by it. Oh, wait a second. Isn't that what I just did with a for loop? I could do a for loop for the y value as well. But I've already got a for loop happening for my x. How do I tell it to do it for the y? And I still need it to do this, these 5 times, or if I make this say 600, then however many times that is. Well, how do I do that? Because I need it to draw all 5 of these where x is 50, and then all 5 again where x would be 110 for the next one, 50 plus 60, and then all 5 again for x being 170. So for every value of x, I need it to draw 5 different stick people. Well, how about I go crazy, okay, and do a second loop with y. And my y starts at 50, so let's do y equals 50. I want this to keep going until while y is less than or equal to 450. So y less than or equal to 450, and each time I want y increased by 100. Curly braces. Okay, so let's kill that. Let's see if there's a way. Stick person x y. Hey, there is my army of stick people going crazy. Now, if only we started making them marching along. I'll get to that later. Loops inside of loops. Now, there's another way we could have done this. If this syntax or the style of coding this looks a little too complicated to you, that's quite okay. We can use another tool called a while loop. And the syntax of the while loop is actually easier to understand. So if you prefer to use whiles while you're learning to code, there is no harm in doing so. So let's show this, and really, there is absolutely no difference between the two methods. So let's show how we'll use a while loop. Okay, so a while loop basically looks like this. So far it looks very similar to a for loop, doesn't it? Okay, except it's a lot simpler. Inside these brackets we only have one statement. And basically we're saying, while whatever's inside this is true, keep doing this. Okay, so I can, if I want to have a variable like x that's keeping track of my coordinates or something like that, I've got to declare it outside my while loop. So let's have a variable x, and we'll start at this time at 120, just to be different. Okay. Okay. Yeah, okay. The auto indenting on this tool is a little odd, but anyway. Alright, so while, let's see, we worked out that about 600 is the end of this screen, so let's go for while x is less than or equal to 600. Draw me a stick person. Okay, now I can just put some numbers here if I want, and I'm going to get a stick person or not, because okay. So my stick person, I want the x. I want to use that variable x as the x coordinate for my stick person, and we'll place in the center of the head at height of 50 for now. Now, what do I need to happen? I need to tell it what to do each loop. The reason nothing's happening over here is because we're actually stuck in this loop. We're never exiting the loop because this is always true. Let's take a look at that. We have a variable called x, and we're setting it to 120. Fair enough. While x is less than 600, keep running this piece of code. Forever and ever and ever and ever and ever and ever and ever and ever. It's always running this piece of code. It's never going to stop because we're not doing anything that's going to make x ever get bigger than 600. So what can we do about that? Well, let's put in another line of code. X is equal to x plus 150. And all of a sudden, we'll have a few stick people. Because we took whatever was in x, we added 150 to it, and then we came back up here. Okay, is x less than 600? Yes, it is. Let's draw another stick person at that value. Let's add another 150 to x. Is x still less than 600? Yes, it is. And we keep going through until we reach the point, is x less than 600? No, it's not. We quit. And only once we quit will we see results on the screen. So, obviously I can change this increment. It doesn't have to be 150. I can make it 50 if I want, and I've got a whole bunch of stick people who are superimposing over each other. And of course, Now, one extra little benefit we actually have here of using the while loop instead of the for loop is that we could change the y inside the same loop if we wanted. So I can do while y is equal to start at 50. Alright, and let's make this a y. So far nothing's changed. And then each time we loop, let's go y equals y plus 50. And what do we get? Oh, well, that's not right. Or is it? Let's look at what's going on. Whilst y is less than 600, draw me a stick person at x and y. And after we draw a stick person, after we draw one stick person, we change the value of x, we change the value of y. And then we go back up. While x is less than 600, draw one stick person, increase x, increase y. And so that's why we're getting this. Because we draw one stick person, we increase x, we increase y. Draw one stick person, increase x, increase y. Well, that hasn't quite worked out. Maybe we can do like we did with the for loop. We can put a while loop inside the while loop. And sure enough, we can say while y is less than, or let's stick with using less than equals. Let's use 600. Okay, let's copy and paste that into there. Let's re-indent that, okay, because we've opened another curly brace. And this time the y, because we're stuck in this y loop here at the moment. So let's make sure the y has a chance to get out of the loop as well. Well, hang on a sec. Now what's going on? It's quite interesting, isn't it? So while y is less than 600, we keep adding 50 to it. Yeah. So why can't we see any extra x's? I'll give you a little clue. Let's change this number from 600. Let's make it 400 before we stop. Okay, so let's look at what's going on here. That clue didn't actually work the way I thought it was going to. Basically, we're not resetting our y value. Okay, so like we did here, outside of the loop, we set this y value. It gets set to 50. We come in while x is less than 600, while y is less than 400. Draw a stick person, increase y. Okay, and it's done it. Draw another stick person, increase y, and it's done it. We've done that while y is less than 400. Fair enough. So we exited that loop once we hit y is bigger than 400. Then what did we do? We increased x by 50. Yup, we did that. And we came back up here while x is less than 600. Yes, that's still true. So we re-enter the loop while y is less than 400. Well, we actually haven't set y to be smaller than 400. Y is still the same number it was back here when we finished the loop the last time. So to come back up, I either need to, when I finish the while loop for the y, I either need to tell it to go back to 50, in which case I'll get that, or I might want to set it at the start, just to make sure that I know that it's going to happen. Okay, does that make sense? I hope that makes sense, because that's a fairly important point. The y was not getting set back to its original value, and so this was never true, and so we were never drawing a stick person. We were increasing our x value each all the way up to 600, but because drawing the stick person was inside the while loop for the y, we were never actually reaching that piece of code. Okay, that is a bit of a summary of what repetition or iteration involves. Now, Obviously, it's a very surface level example, just drawing a whole bunch of stick figures on screen. But there is immense power behind the for loop and the while loop. For example, reading through all the records in a database. Okay, whilst there's another record to read, keep reading the database. Same with reading the contents from a file, loading them up, to use for your program, whether it's a file of high scores, or maybe it's a file containing words to use for a hangman game, or maybe it's messages that have been sent over a network, or whatever. We will use loops, iteration, repetition, a lot in programming. And we tend to use them in combination with functions like this. So, practice on your own, and I will see you next time. Please remember to save your work. All right, this is Mr. Baumgarten, signing off.